Alright everyone, let's get into some actual problems with vectors by doing some properties with them. For instance, so we're still in section 6.4 vectors. Okay, so vector addition is the first thing we're going to talk about. So if the vector u is AB and vector v is CD, then u plus v is equal to A plus C and B plus D. This is our vector addition. Now, u plus v here, this is called the resultant. Okay? It's the same thing as the resultant. And the sum of a vector can be interpreted geometrically. One way it can be interpreted is the tail to tip rule. Tail to tip rule. And basically what it says is this. If we start with the tail of vector u and we run its tip to the tail of vector v, then this distance here, this distance right here, is vector u plus vector v. Now that's one way to look at it geometrically. Another geometric way to look at it is called the parallelogram rule. Let me go to the next page to do this. It's called the parallelogram rule. And so, parallelogram rule. Okay, so what it basically states is if u and v are not parallel. So let's say this is u and this is v. They're not running in a parallel direction. Then if we look at the parallelogram of these, if you think of this as a parallelogram, then the resultant, or u plus v, would be this distance right here. It would be the distance of the diagonal. So that would be u plus v. So that's two different ways of getting to the same result, okay? So don't let that confuse you as you are working these problems. All right, so another thing that that you're going to want to know is scalar multiplication. Scalar multiplication. And basically what it says is if we have a vector like this, and let's say k is a scalar, meaning it's some quantity that we're going to multiply through this vector, then k times vector u is the same thing as k times AB, which is the same thing as k times A and k times B. Now essentially what we get here is this is the way that we do subtraction. Notice we had an addition rule. We don't have a subtraction rule. So use of a negative k could be a way to do subtraction. If k is negative, when you're figuring magnitude, you still have to do this is where the absolute value of the vector for magnitude, that's where that's going to come in. because if you multiply by negative k, then it would look like you had a negative magnitude. And remember, magnitude is the size. That can't be negative, so that's where that absolute value comes in from before. Now, if k is positive, so if k is greater than 0, our vectors are going to be in the same direction. But if k is negative, our vectors are going to be in opposite directions. Opposite directions. All right, so let's actually look at some examples of these. So let's let vector u equal negative 5, 3. Let's let vector v equal 4, negative 6. And let's let vector w equal negative 2, 0. All right, so letter A. Let's do it simply first. Let's find vector u plus vector v. Well, that is going to simply be negative 5 plus 4 and 3 plus negative 6, which is going to be a negative 1, negative 3. A negative 1, negative 3. Okay, let's look at another one. Now here's where we're going to multiply with a scalar. Okay, here's where we multiply with a scalar. So negative 3 times vector u is the same thing as negative 3 times negative 5, 3. Excuse me, that should be positive. So that's going to be negative 3 times negative 5 and negative 3 times 3. So this should give us a new vector of 15, negative 9. Of 15, negative 9. All right, well, what about 3u minus 2v? See, this is where the scalar multiplication is where we get subtraction, because we really don't have a way to subtract as of yet. So the way you're going to write this, of course these are vectors, that's going to be 3 times the negative 5, 3, plus negative 2 times 4, negative 6. So you see what we did there? Remember, subtraction is the same thing as plus a negative, which is how we're portraying this so that we can solve it. So this is actually negative 15, 9 here, plus negative 8, 12. All right, so when you get to this point, you're done with the scalars. So now you can just add. So negative 15 plus negative 8 is going to be negative 23. And 9 and 12 is going to be 21. So there's my vector. So hopefully that makes a lot of sense to you. Hopefully it's pretty easy, and we'll be able to knock this out pretty quickly with these kind of problems. Now in our next video, I'm going to cut this one off here because I want the next video to be solely about our next topic, which is going to be unit vectors. So we'll get to that in just a moment.